everyone.
Bye. Evening, everybody.
Although today it's taken for granted that every office has a fax machine, only a few years ago it was almost unknown. Its recent appearance has made it a wonder of the age, and there is something quite magical about the way it converts a bit of paper into a stream of odd warbling noises and then reassembles it all at the receiving end. But although it seems quite magical, the basic way it works is actually surprisingly simple. We're going to demonstrate this principle with a human fax. Rex has got a big bit of paper just over the ridge, and I'm going to fax this message to him using these flags to signal to him. We're going to walk over our bits of paper using metronomes to keep us in step, and I'm going to hold up the green flag to signal the start of each line, and I'm going to hold up the red flag whenever I step on a black bit of the paper. What's happening inside a real fax machine is surprisingly similar. There's a sensor that reads a line at a time at the sending end and a printer that prints out a line at a time at the receiving end. The lines are usually much too small to be visible, except at the tiny writing at the top of a fax, which identifies where it's come from. Of course, there's a mass of electronics underneath that converts the lines to sounds that can travel over the telephone. But the basic idea is exactly the same as our human fax. It's so simple it was first patented 150 years ago, long before the era of electronics and over 30 years before the invention of the phone. The inventor was a Scotsman called Alexander Bain, who came from a remote croft in Caithness.
Things. Nothing to do. There must be more to life than sheep.
His interest in the new science of electricity was inspired by a lecture, and he started experimenting in 1840. Buying only a coil of wire, he used cattle jawbones for hinges and heather for springs. He made batteries by sinking plates of different metals into the earth.
I'll teach you about the inner workings of the clock, young Bain.
During his apprenticeship, he invented the first electric clock.
What have you done?
Look, sir, the first electric clock.
That's hideous. Go away.
There's no place for me here. I shall go to London. Aye, and I'll invent the first fax machine.
Bain's fax machine was inspired by an earlier discovery that paper soaked in potassium ferrocyanide turns black when electricity is passed through it. So if I put it on this metal plate and move a nail across it, it should change colour when I complete the circuit. Bain had the idea of using this paper to receive messages assembled out of printer's type. So if Rex, with a bit of help from Percy, moves his nail across the raised part of a bit of type, while I move my nail across the paper, we should be able to send the message in a series of lines, just like we did with the human fax. Of course, this time the message is being sent by pulses of electricity, so it can be sent like Morse code along telegraph lines. Bain fixed the nails at the sending and receiving ends to the pendulums of his electric clocks. This kept them in sync, however far apart they were. However, having patented the idea in 1843, he never developed it. The oldest existing fax machines are in the Musée National des Techniques in Paris. These magnificent contraptions, called pantelegraphs, were built by a French engineer called Abbé Caselli in about 1860. They're the same idea as Bain's machine, but Caselli had perfected them, and these actually ran the world's first commercial fax service between Paris and Lyon. The message to be sent was wrapped on one of these curved plates. Instead of Bain's raised type, it was engraved out of very thin sheets of copper. These machines don't work anymore, but there would have been a stylus in here, the equivalent of our nail, to make the contact, and it was moved across the message by this large pendulum, attracted from side to side by the large electromagnets. At the receiving end, you'd put a bit of Bain's soggy paper on one of these curved plates with another stylus resting on it. Then, if you got the two pendulums swinging together, the message could be reproduced. In practice, getting the pendulums to swing together 250 miles apart wasn't at all easy. They had to have a separate clockwork chronometer at each end to get them in sync before the message could be sent. The definition the pantelegraph achieved is really quite extraordinary. Unfortunately, though, it was too far ahead of its time. The pace of business life was so slow that there wasn't any real demand for it, and it was abandoned after only 4 years due to lack of customers.
The thing that revived interest in fax machines after Caselli's failures was the discovery of how many electrical materials were sensitive to light. In fact, this is quite a common phenomenon, and most semiconductors are light sensitive to a degree, and if I cut the top off this power transistor, I can show you. It's connected up. You can see on the meter when I put my hand over the transistor to cut the light off, the resistance goes down. When I remove it, it goes up. And you could use this as a light sensitive switch.
In a fax machine, light-sensitive switches made it possible to send messages written with ordinary paper and ink, and photos, and in fact any black and white image. This is because they work not only with a beam of light, but also with reflected light. Now, I've got a sawn-off transistor here. If I hold it over a bit of paper brightly lit by a spotlight, only the white parts reflect enough light to switch the transistor. This is basically how a modern fax machine reads an image. The paper is focused onto this brightly lit slot, and a line at a time is focused through this lens at the back and onto the read head. I don't think it likes me fiddling with it. Inside there, 1,728 tiny sensors, basically miniature versions of my sawn-off transistor. This is the earliest existing photo sent by fax in 1906. By the 1920s, fax had become a standard way of sending newspaper photos.
Speed, the life's blood of a newspaper. Speed, speed, speed. Train, telegraph, airplane, telephone, and radio. Get the story, get it to the paper, get the paper on the street. Every available development of science and engineering has been utilized to get the story to the reader in the shortest possible time. And now, the latest miracle of news gathering, sending pictures by wire, has lifted the curtain on a new era in newspaper history. It is only a matter of minutes after a news event has occurred before newspapers all over the country are carrying pictures that tell the story more graphically and completely than the printed word by simply picking up a telephone and calling the paper.
Most of these machines work by wrapping the picture around a drum and then moving a single sensor slowly along it. This model shows the basic idea. The page transformed into a string of black and white bits and then all recombined at the receiving end. Rex and I have had a go at sending a fax like this using our lathes. I'm going to send this message to Rex. This is my light sensitive switch, the sensor. I'm going to put that in the lathe here. Clamp it in. Now I've connected it up to this little sounder so that it'll squeak whenever it passes over a black bit of the message.
This is a soggy paper, like we used over at Tim's workshop. Now I'll put this paper around a drum on my lathe, and this piece of wire represents the nail we used. Now this little sensor, this microphone, I'll put on the loudspeaker of the telephone, and when it picks up the bleeps from Tim's sender unit on his lathe, it will leave a mark, it will go through here, leave a mark on the paper by a sound sensitive switch, and the same thing as if I shout into it. If I start the lathe up, hang on. If I start the lathe up, and you actually see it, the little light will come on if I shout, "Hello!" You can actually see the smoke coming off the paper where the current's going through. "Hello! 1, 2, 3, 1, 2, 3. Switch off again. And then you can actually see the black marks left by my voice. Anything coming through yet, Tim? Tim?
Can you hear me, Tim?
Yeah, I can hear you.
Can you send me a sync pulse through?
Yeah, I just have to tape the thing to the phone.
Okay.
So with the microphone and my sounder connected to the handsets of our phones, we should be able to fax the message.
Okay, I'll tape mine on.
Okay.
I'll just tape that onto the edge of the speaker.
Right, get the lathe going. The only thing is, first I just have to send a pulse once a revolution, because Rex has got to get his lathe going at exactly the same speed as mine. Can you hear the pulse?
Right, Tim, we got sync. Can you hear me? Okay. Well, it's coming through quite clearly now. I can even see the first line. Before I stop it, it says Utopia. I'll stop the lathe. Ah, yes, the first line is, yes, it's Utopia, and the second line is services, but it's very wobbly. It's a job to keep it in sync, but it's not bad for a lathe.
This is the Met station at Hemsby, where they send up hydrogen balloons with cheap disposable instruments attached to record weather conditions in the upper atmosphere. The information from sites like Hemsby all over the country is collected at the Met head office and assembled into the weather map. A completed map is then sent back here by fax. Although it looks quite neat and modern, the fax receiver is actually still endearingly primitive. It still uses Bain's soggy paper, and inside it's all very mechanical still. Looks a bit like a lawnmower, actually. We'll just stop it. This rotating helix, the bit in contact with the paper, slowly moves along the line. from one end to the other. It has considerable drawbacks. For a start, it only works with dedicated phone lines. It creates quite large sparks across the paper as it prints out the message. And this means that this contact strip has to be replaced every day or two. Also, the paper stops working as it dries out, and the vapour it gives off can be a health hazard. The machine's days are now numbered. They're gradually being replaced by a computer system. It is extraordinary, though, that although fax machines have had specialist uses like this for over 50 years, that they've only come into general use in the office in the last 5.
Every year, more than 200 million telegrams pass through the hands.
The main reason why fax machines took so long to catch on is that an alternative system for sending written messages by telephone lines had already become established, the teleprinter and telegram service.
The keys are punched. The distant receiver records each letter on a moving paper tape. An operator removes the tape and gums it to the familiar yellow blanks.
Bain had pioneered teleprinters after he abandoned the fax, but he got involved in furious patent battles.
Mr. Bain, the court finds you did not invent any of these things.
That was my patent. Why did I leave Scotland? At least I could trust my sheep.
He died, bitter and penniless, in a home for incurables in 1877.
You are about to witness a race between the Xerox telecopier transceiver and Speed Johnson, one of the fastest messengers in the world. They will both attempt to get a copy of this important document to a destination at the other end of the city. And they have to get it there in 4 minutes or less. Okay? On your mark. Get set. Go! Speed will be using an ordinary motorcycle. The telecopier, an ordinary telephone.
By the 1960s, electronics had advanced enough to revive interest in office fax machines or telecopiers. They were very expensive, slow, and different manufacturers' machines were all incompatible with each other.
The telecopier copy has just arrived, ladies and gentlemen, in exactly 3 minutes and 57 seconds.
The development that really made the fax machine practical was the digital fax. This not only split the image up into lines, but into a complete grid of tiny squares. So first you have to put a grid over the image, and then decide which squares are going to be white and which squares are going to be black. That's what I've done down here. Well, now I can send this to Rex just like I did at the beginning of the programme, square by square. The only difference is that this time Rex needs an assistant, because Rex is going to have to look at what he's doing to get the paint exactly in the squares. He's got a similar grid with the squares marked out just like mine. Right. Okay.
Stop! Black! White! Black! White! Black! White! Black!
The big advantage is that Rex should be able to reproduce exactly what I'm sending. Even if I hold my flag up at slightly the wrong moment, Rex is unlikely to fill in completely the wrong square. It's this precision that makes it possible to send digital faxes much faster without losing any quality in the reproduction. A mathematician called Huffman worked out all the possible codes for the different run lengths of black squares and white squares. And he gave the shortest codes to the most common run lengths on an ordinary typewritten letter. If I put a mask over a line of the type, hold a magnifying glass over it, you can see that there are a lot of thin black lines. These are actually each 2 squares wide. And if you look on the Huffman code, you can see, because this is very common, it has a very short code. If you look at the white spaces between the lines, you can see they're all much more variable in width. So all the white spacing have longer codes. This is the same idea as Morse code, where the vowels have shorter codes than the less common consonants. And this explains why fax machines slow down when they're scanning a complicated image like a photograph and speed up when they get to a bit of text. The familiar thermal fax paper simply works by turning black when it gets hot, which we should do in front of this fire. A small heating element can blacken a very precise area of the paper. This is basically what's inside the thermal printer of a fax machine. It's a row of 1,728 tiny heating elements, one for each digital square of a line. The only moving part is this roller that feeds the paper through the printer. This simplicity not only makes the machine very cheap, it also makes it extremely reliable. The electronics in a fax machine are complicated not only because of all the digital coding, but also because the machines have to talk to each other to start the message going. This handshake procedure is pretty complicated. Telecom Research have lent us a fax analyzer to show what's going on, but the process is actually quite closely analogous to starting a telephone conversation. So if I ring Rex now, what's this on? 525, all right. You're engaged.
It's fine, so I'll switch that off.
Yeah, switch this off, yes, all right then. Stop.
Well,
Stop.
That's
it. Okay, I'll try you again.
Hello, Rex here. You'll have to speak up.
Hello, Tim here. Can you understand me if I speak this fast? Waffle, 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 waffle,
Yes, I
waffle,
understand
waffle.
you.
Okay, waffle, 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 waffle. That's all I've got to say.
Okay, everything understood. Bye.
Bye. And that completes the handshake procedure. Although the handshake is complicated, it happens completely automatically, so the machines remain extremely simple to use. What shall I have today, then? I'm sure this is why they've become so popular in the office.
Mr. Jones? What are you playing at? This is an office, not a fast food emporium.
Ooh.
Knitting pattern? Joan? Is this for you?
Oh.
I've told you 100 times, don't use the fax for your hobbies.
Oh, sorry.
Oh, really? Polly? I'm expecting a very important fax for work. I do not want the machine abused for private use. And that goes for everybody.
Ooh.
This is the last straw.
Oh, here you are, love. Nice cup of tea. And we've got your private fax of your very own. Happy now?
I hope I've managed to demystify these inscrutable machines a bit in this programme. I have to admit, though, I don't find the modern machines quite so appealing as the early ones. I came back from Paris so enthused by the pantelegraph that I couldn't resist having a go at trying to make one. It might not be completely practical in an office, but there is something rather hypnotic about it.